Hello. After watching this video, students will be able to utilize tools in SolidWorks to check the draft angles of a part, ensuring that the design will be manufacturable by means of injection molding. As shown here in SolidWorks is a basic extrusion of a rectangle, which has added fillets to each edge. In order to be able to check the manufacturability by injection molding, the fillets and radii of a part should be as generous as possible. The desirable minimum under any part, however, is 0.5 millimeters or about 0.020 inches, being that a 1 millimeter fillet is the most preferable. To determine if the fillets and radii of the part is able to be injection molded, there is a built-in tool in SolidWorks to help check. Underneath the Evaluate tab of the Command Manager, there is a button for Draft Analysis. Once that is clicked, a Property Manager will appear on the left side. The analysis parameters contains the direction of pull in relation to the pull of cavities which release the injection molded part, as well as the minimum desired angle to analyze. By selecting the front plane in this case for my analysis parameters with a draft angle of 3 degrees, the part is then colored in with a type of draft that occurs as indicated in the Property Manager window under Color Settings. Here, there is an option to select a gradual transition color, which is defined as a spectrum, as you can see. The box is unchecked to show the basic tool. As described, there are currently 3 colors to indicate the type of draft on the part. Green being positive draft, yellow being requiring draft, and red, which is negative draft. Currently, there is all positive and negative draft, as you can see when I rotate this part, and that's a good thing. If I switch the direction of the pull, the current positive green draft should be shown as red, and the current red negative draft should be shown as green. And that is what occurs, as you can see. However, when we change the draft angle to, for example, 30 degrees, there is a portion of the part which now requires a larger fillet, as indicated by yellow. Changing it back to 3 degrees for the draft angle, if we were to analyze the part from being able to be injection molded by a different direction as a pull, such as the top plane, it can be seen that the part is unable to be injection molded due to the draft angles required of 3 degrees, but as I hover right here, you can see that the draft angle is 0 degrees. This process can also be done as demonstrated by a more complicated part, such as the top half of a AC LED driver, where if I apply the same criteria going underneath Evaluate to Draft Analysis and selecting the analysis parameter of the plane of pull to be the top plane, you can see that this part will be unable to be injection molded from the perspectives of actually all 3 planes whenever I cycle through each plane, in that there is the yellow portion which does not have enough draft in order for the part to be manufacturable.